Welcome to June 30th LeetCode Challenge. Minimum moves to equal array elements 2. Given an array of integer array nums of size n, return the minimum number of moves required to make all arrays elements equal. In one move, you can increment or decrement an element of an array by 1. Test cases are designed so the answer will fit a 32-bit integer. So we're given the following nums, 1, 2, 3, and what is the minimum number of moves you can make by decrementing or incrementing an element in the array by 1. So if we were to say in one move from here to here, increment the first element by 1, making it equal to 2, therefore we have 2, 2. And then the last one, we decrement the third element by 1, therefore we have all array of 2's in there. Alright, next one is pretty similar. We would find out that we would have a 16 moves to make sure that we have to decrement or increment. Well, ideally, actually, for this one, we would have to make them all the same, right? So the constraints of the n is equal to the length of nums. The length of nums is between 1 to 10 to the 5. And each index I of num is between negative 10 to the 9 to 10 to the 9. So in this question, we're going to ask ourselves, so given the integer array nums, so basically you could choose any element in the array, increment or decrement the other elements, and make them equal to the chosen element. So first of all, we're thinking about maybe sorting the array. And then if we sort the array, we're going to have to find the moves required to make the array all equal. How do we do that? And for for that, we're going to choose the middle element, an increment and decrement, to make sure the elements are equal to, so that will be the minimum amount of movements. So the idea or the approach would be to make all the values equal. The number must be converted to every other number is the median of the array. Right? If you just think about it. Example 1, the median of the array is 2, so therefore if you convert every number to 2, it will be the most minimum number of movements you can make to make all the arrays equal. And there's a proof for that, but I'm not going to really demonstrate it. It will just show up by the code. So since the middle number, the median meaning the middle number, you need to find the minimum number of operations. Now you want to ask yourself, what are those cases, right? Those edge cases. So the length of the array is even. So where do we get the two medians? Well, any one of them is fine, right? We just pick one of them and choose that. And then we subtract the value from the other element of the list to get the absolute value. Then just add all the absolute values together, and that'll be the answer. So let's kind of go about doing that here. So the first thing we want to do is sort the array nums. Sort. So once you sort it, next thing we want to do is obviously get the length of it. Length of nums, and then we want to find the output, which is going to be a variable which we're going to increment, and then we're going to find the median as well. So median is it, how do you spell it? Median, probably mid actually sounds a lot better, and that's going to be the median is going to be the middle number between the array, so that will be size n, integer division by 2. For index I in the range of n, so we iterate through each element, we just need to find whether it will be incremented or decremented. So in order to do that, we just kind of output to be the incrementer of the absolute value of the difference between each number minus the midpoint or the median, and then we just return the output. So it's pretty straightforward in terms of the calculations. Hopefully this gets accepted. Oh, nums. Let's try that again. Submit. Alright, accepted. Oh, nice badge. Right. So the time complexity will be big O of n log n, because the sort algorithm here, plus n of the for loop. Big O of space complexity is actually big O of constant space, because we just return a variable number. And that's it. Have a great day, guys.